Hello students, this is Niteen Mohod and here we are going to see the concept of inductors. Inductors are basically the coils. They are the electromagnetic components, means which are exhibiting the properties like magnetic and inductive. It's basically a coil wound on a core or former of suitable material and providing the property that is inductance or a parameter you can say. It mainly opposes the change in magnitude of current and its basic unit is Henry. It's also called as choke, reactor or coil. These are the synonyms. So for the classification of inductors is concerned, inductors are broadly classified as fixed inductors and variable inductors. Fixed inductors are further classified as air core inductor and core inductors. Air core inductors means there will be nothing inside the coil, and core inductor means there will be some material which will be called as a core of the inductor. Core inductors are broadly classified as ferrite core inductor and iron core inductors. We are going to see one by one here. Inductors are passive components capable of storing electrical energy in the form of magnetic energy. So here you can see the picture of how the air core inductor looks like. It's basically a coil. Number of turns of the wire is wound on a former made up of plastic, ceramic, ordinary cardboard, or you can say there is nothing inside, means air core, or any other non-magnetic forms. So this type of construction the air core inductors are having. Since there is an air inside the former, it is called air core inductor. It has least inductance, that is the minimum inductance it is having for given number of turns and core length. This is the symbolic representation of air core inductor, and it is used in constructing radio frequency tuning coils. Then it can be used in filter circuits also, and snubber circuits. Snubber circuits means the energy absorbing circuits which can protect the switching diodes in switching diodes from the spikes, voltage spikes you can say. It is also used in high frequency applications including TV and radio receivers. Moving on to the next category, that is the iron core inductor. Here you can see the coil, and within the coil some core is provided, and here the core which is provided is the iron core, and that's why the name iron core inductor. Here the coil is wound on a solid or laminated iron core. The laminated iron core is basically to reduce the eddy current losses. Eddy current means the circular current which is flowing inside the coil, and the losses which are existing across the resistance, they are actually the I square R losses. To avoid these losses, the core is laminated basically. Laminated iron core consists of thin iron laminations pressed together but insulated from each other, and these are to reduce the losses which are the eddy current losses. Such inductors are also called as choke, and this is how the symbolic representation of the iron core inductor is. Iron inside inductor increases the inductance many times that of relative permeability. Now permeability is what? It is represented by mu r, and permeability is basically the ease with which the flux is created in the material. Applications of iron core inductor: in filter circuits, to smooth the ripple voltage, the iron core inductors are used. Then they are used in AF applications. They are used as AF choke in fluorescent tube lights. They are used in industrial power supplies also, and in inverter systems, along with the power conditioning. The next category of the inductor is the ferrite core inductor. Now the ferrite is a ferromagnetic substance Ferromagnetic substance means here ferro stands for iron and magnetic means material which is attracted by the magnetic field. It consists of wire wound on a ferrite core. So you can see in the picture. So here the material which is shown inside the coil, this material is a ferrite material. It's a solid material, consists of fine particles of iron powder embedded in an insulating binder. This core has minimum eddy current losses. Ferrite inductors used at high and medium frequency since it has high permeability with low loss. Large inductance possible with the ferrite core. This is the advantage of the ferrite core inductors, that you can have the large inductance inductors. And this is the symbolic representation of the ferrite core inductor. So for the applications of ferrite core inductors are concerned, they are used for power transformers in the frequency range of 1 to 200 kilohertz. They are used in switching circuits and in coils to be operated in frequency range of audio frequency, that is 20 hertz to 20 kilohertz to 100 megahertz. I hope the idea of inductors, their broader classification, the different types of inductors which we have discussed here, and their applications are clear to you. Thank you.